Hello, everyone. In this lesson, we will focus on Task 3, Using and Simulating with TIA Portal. The target results to be achieved through the study of this task include 1. To understand the components and their meanings within TIA Portal. 2. To be able to create a new PLC project using TIA Portal. 3. To perform online simulation using TIA Portal. The knowledge structure of this task comprises two parts. The first part covers the integrated software systems within TIA Portal. Primarily, we use SIMATIC Step 7, which is essential for PLC configuration and programming, and is the main software we will study in this course. Additionally, there are SIMATIC WinCC for HMI configuration, SIMOTION for servo motion control, SYNAMIC Start Drive for frequency inverter setup and debugging, and SIMATIC Safety for safety monitoring and control. The second part covers the use of PLCSIM simulation software, which allows us to validate the correctness of PLC programs through online simulation of the program, timing diagrams and trace, and sequence simulations, all without the need for actual PLC hardware. Now, let's introduce Siemens TIA Portal. It is an integrated automation software platform launched by Siemens, which combines multiple software systems for various automation tasks. The most commonly used software is SIMATIC Step 7, Siemens standard software for PLC programming and configuration. It supports multiple PLC series including S7-300, S7-400, S7-1200, and S7-1500. It is mainly used for logic control, data processing, and automation task programming. Another commonly used software is SIMATIC WinCC, Siemens HMI configuration software used for designing and operating the monitoring and control interfaces of automation systems. It is mainly used in the monitoring layer of factories and production lines, allowing operators to monitor and control the production process via graphical interfaces, and providing alarm handling, data logging, and reporting functionalities. Next is SIMOTION, a motion control product series from Siemens that integrates PLC, motion control, and HMI functions. It is used for complex motion control, position control, speed control, and is applied in applications such as robotic arms, packaging machinery, and printing machinery. SYNAMIC Start Drive is another Siemens software focused on drive configuration and debugging, specializing in frequency inverter parameter setting, debugging, and optimization. It is suitable for simple drive control applications like starting and stopping a single frequency inverter, speed control, and torque control. Finally, SIMATIC Safety encompasses a range of safety-related software and hardware products from Siemens. Widely used in industries with high safety requirements such as chemical, energy, pharmaceutical, transportation, and mining sectors. It enables users to achieve safety monitoring and control of critical industrial processes, ensuring personnel safety and equipment integrity. Let's use the example of motor start control to explain the use of TIA Portal software. First, double-click the TIA Portal V16 icon on the desktop to start the TIA Portal software. Choose to create a new project. Change the project name. And click the Create button. With the default Getting Started option, select Configure Devices and add a new device. There are three types of devices: controllers, HMIs, and PC systems. We select Controller and find the PLC model list. Choose S7-1200 and select the CPU model that matches the physical PLC. Here we choose CPU 1214C DC/DC/DC, and the order number that matches the physical PLC version. Select the third option with the highest version 4.4 and click the Add button. Next, we enter the project view interface of TIA Portal. The left side is the project tree, showing the newly created project and selected PLC model. The middle section is the device view, showing only the selected PLC. Next, we will change the IP address settings for the PLC. Select PLC_1, then go to Properties. In the General tab, choose the Profinet interface under Ethernet address options. Enter 192.168.0.1 in the IP address field, ensuring that the first 3 octets match the IP address of the computer, so that the PLC and the computer are on the same subnet. Default subnet mask. On the right side is the hardware catalog, where you can select the CPU, signal boards, and expansion modules, DI, DQ. In the project tree, select Program Blocks, and double-click Main to enter the programming interface of the ladder diagram. Before explaining PLC programming, we need to define the input and output variables. Click on PLC Variables, double-click the default variable table, and input the following. Start, data type, bool, and address, I0.0. Stop, data type, bool, and address, I0.1. Motor, data type, bool, and address, Q0.0. Return to the main program interface and drag the normally open contact into program segment 1, along with the normally closed contact, the coil, and the normally open contact that requires self-locking. Double-click the red question mark to find the Start button I0.0, the Stop button, and the output coil for the motor Q0.0. Set the self-locking contact to motor Q0.0 as well. This completes a simple ladder diagram setup. Before downloading the program, click the Compile button to check for basic instruction writing errors. If compilation completes with 0 errors and warnings, proceed to download the program to the device. In the Configure Access Nodes section, we see PLC_1. For the PG/PC interface type, select PN/IE and choose the network card type that connects to the physical PLC. Since the computer uses a USB network card, select the USB 2.0 adapter. Start the search. And the physical PLC is found. Click Download. And choose to continue in case of a mismatch. Before downloading, we need to stop all devices, and then click Load to complete the process. This way, we can download the program segment to the actual device. Okay. After watching the recorded demonstration, do you now have a better understanding of using and simulating with TIA Portal? I hope you will practice more and master the usage methods. That concludes this lesson. See you next time.